Good morning student, myself Mili Sakla, and in today's session our subject structural analysis part 1 we solve the example of moment area method for simply supported beam. Okay, now first of all start the example. We read given data properly. Here in this example, for simply supported beam subjected to UDL load on entire span and find out slope at support and deflection at mid span using moment distribution method. Okay, so first of all we draw the simply supported beam. Okay, this is our simply supported beam, and this simply supported beam subjected UDL load. Okay, this simply supported beam subjected to UDL load on entire span. Apply this UDL load, okay, on the entire span. This is A point and this one is B point, and load is equal to W kilonewton per meter. Distance is equal to L. First of all we find out support reaction. Our support reaction RA and RB is equal to WL by 2. Okay, we can use taking moment about A also. This is beam a symmetrical beam, so take WL total load divided by 2. And second, we already study in MOS moment at C. Our moment at MA and MB is equal to always 0, and moment at C is equal to WL square by 8. Okay, and this moment diagram of this simply supported beam is outward parabola. This is A point, this one is B, and this intermediate point plus, and moment we find out here WL square by 8 EI. Okay, WL square by 8 EI, and this diagram is our M upon EI diagram. So write here M upon EI diagram. Okay, and this one is our deflected shape. This is A point, this one is B point, and this intermediate point is C. Now first at B point our deflection is Y1. Okay, beam is deflect like this way. Look at this. Here we apply our moment area theorem number 2. Displacement of point B from tangent A is not this point BB dash. Okay, here is our deflection, and this deflection is the YC we take, and this extra deflection at center point we take Y2, and summation of this YC and Y2 we take Y3. Clear? This is our Y2. Now deflection, displacement of point B from tangent A is equal to moment of M upon EI diagram between B to A, and this is the deflected shape right here. This is our deflected shape. Okay, now one by one we find out deflection. Now first of all right here we find out YC, and this YC is the difference between Y3 minus Y2. First of all we find out Y1. So right here Y1 is equal to moment of M upon EI diagram between B to A. Okay, because moment is deflection, and about B because we find out CG from B point. Now area of this first diagram is equal to 2/3 because outward parabola, 2/3 into distance L into WL square by 8 EI, and CG of this beam, this is L by 2 and this one is L by 2, and CG of this semicircle is equal to L by 2. Okay, now answer of this Y1 is equal to Y1 we find out WL raised to 4 divided by 24 EI. Okay, from this, look at this, from this symmetrical point we can take this distance is our L by 2 and this distance is our L by 2. In trigonometry we learn that side angle side, Y1 by this L is equal to Y3 by this L by 2. We take a similar triangle. Okay, now here again I draw the diagram. This beam is our simply supported beam. Okay, and this simply supported beam subjected to UDL load. Okay, this is our deflected shape, and this point is our YC, this point is our y2, and summation of this two value is equal to y3. This one is y1, A point, C point, B point. Okay, and diagram outward parabola. Here height W L square 8 EI plus A, then B point, and intermediate point is C point. Okay, now next, this distance is L by 2, this distance L by 2. Take a ratio y1 by L is equal to y3 by L by 2, and y3 is equal to y1 by 2. y1 we find out W L raised to 4 24 EI into 2. That means W L raised to 4 48 EI. Clear? This is y3. Now next we find out y2. Okay, now we find out y2. Okay, and y2 is equal to, right here, value of this y2. y2 is equal to moment of, write down, moment of M upon EI diagram, moment of M upon EI diagram between C to A and about C. Now one by one, area is equal to 2/3 into distance L and W L square 8 EI, and from CG 3/8 into L by 2, because this is our quarter circle. Okay, 3/8 of CL, and y2 is equal to, answer is equal to W L raised to 4 divided by 128 EI. Okay, now we find out YC. YC is equal to simply y3 minus y2. y3 we find that is W L raised to 4 48 EI minus W L raised to 4 120 EI. Okay, now final answer of, okay, now YC is equal to, right here, value of YC. YC is equal to 5 by 384 W L raised to 4 EI. Now we find out slope at support. Right here, slope at support. Okay, from our deflected shape, here we write down y1 is equal to theta A by L. That means theta A is equal to y1 by L. What is the value of this y1? y1 is equal to W L raised to 4 24 EI into L is equal to W L raised to cube divided by 24 EI. Now due to symmetry, right here, due to symmetry, okay, due to symmetry, theta A is equal to our theta B, because simply supported beam subjected to UDL on entire span, that is equal to W L cube 24 by EI. Okay, here our example of moment area method for simply supported beam subjected to UDL on entire span is complete. Okay, just now we stop here.